Hello friends, I welcome you in my YouTube channel. I am Dr. Sirajul Faisi. Today in this video, I am going to talk about nucleophilic substitutions at saturated carbon atom. So let us start. What is the meaning of nucleophilic substitution at saturated carbon atom? You can see these reactions Rx and nucleophile forming R nu and plus X minus. Here X is called leaving groups and Nu is called nucleophile. It attack on the alkyl carbon and forming nucleophile alkyl substituted products. So this reaction actually started with the nucleophile. So it is known as nucleophilic substitutions reactions. Now friends, there are many types of or many reactions which is showing nucleophilic substitutions reactions. You can see the formation of alcohol, formation of ether, formation of nitriles, formations of mercaptans, formation of sulfides, formations of amines, and formations of ester. Now friends, I will show you. You can see the substrates. Substrate contains leaving group, here Br, and nucleophile OH minus and forming methanol. So there are two reactions. One is SN1 substitution nucleophilic unimolecular reactions. You can see the formation of carbocation Rx, slow, forming carbocation intermediate, and step 2, capture of the carbocations by nucleophile. So R plus nucleophile give the fast products. Now friends, you can see this is the one example, T-butyl chloride or tert-butyl chloride, forming tert-butyl carbocations. You know 3-degree carbocation is more stable. It is stabilized by hyperconjugations, and in the second step is ionic type reactions, and it is fast, forming tert-butyl alcohol. So this is the reactions progress. There are two transition state for ionizations and transition state captured by nucleophile. So you can see here RCl and formation of R plus Cl minus and then R nucleophile. What is the stereochemistry of SN1 reactions? You can see the compound is chiral nature after leaving groups forming carbocation. So there are two chances of attack, from the top and from the bottom. So inversions, predominance and retentions. So both product is forming, so racemizations occurs. You can see in these reactions Rx, R plus X minus and R plus X minus, and then separated out. So the formations of reciproc mixtures, you can see in these reactions also chlorine is transformed with the OH, and there is a retentions and inversions 51% and 49%. So friends, solvents play important role in S1 reactions. Polar solvent preferred SN1. Effect of nucleophile on rate. The rate of SN1 reaction is independent of the nucleophile. A better nucleophile will not accelerate the SN1 reactions, and yet it may determine which product is formed. Effect of leaving group is also important. the rate of SN1 reaction is largely influenced by nature of the living group. Rearrangement in SN1 reactions is also happen. You can see in this example 2-bromo-3-methylbutane forming carbocation, and this carbocation is hydride shift. Rearrangement occurs and formation of 3-degree carbocation, and then fast nucleophile attack and forming 2-methyl 2-butanose. So rearrangement occur in SN1 reactions. You can see here also how nucleophile attack on 3-degree carbocation rearrangement. Effect of nature of substrate on the rate, that is also very important. Stability of carbocation 3-degree, allyl benzyl 2-degree, 1-degree and methyl. Third, alkyl halides, allyl halides, benzyl halides, S-alkyl halides, 1-degree alkyl halides. You can see the benzyl chlorides resonance stabilize, allyl carbon also resonance stabilize. Here you can see this is the methoxymethyl chloride is also resonance stabilized. You can see this bridge one. Now friends, you know about the SN2 nucleophilic substitution, nucleophilic bimolecular reactions. In this reaction especially transition state is formed. So Rx nucleophile forming transition state and then RNA. So rate of reactions directly proportional to Rx and nucleophile. So friends, you can see the transition state is only one transition state, but in SN2 you have already seen SN1 two transition states. Rearrangement in SN2 reaction, you can see here Br is living groups and the rearrangement occurs and nucleophile attack here. In the same way in the second examples. So refer to an SN2 prime reactions. You can see the SN2 and SN2 prime reactions. Now friend, stereochemistry of SN2 reactions. Most of the SN2 reactions proceed with complete inversion of configurations of the substrates. You can see the nucleophile attack and forming the transition state, and this transition state happen in SN2 mechanisms, and then you have the product and product showing the Walden inversions. You can see the transition state and forming 2-octanol. Now friends, effect of nature of substrate on rate. The steric hindrance around the carbon site makes a huge difference in the rate of SN2 reactions. You can see in this molecule neopentyl halides, there are bulky group CH3 stud butylase group is here. Effect of nucleophile, you can see the SH react with sodium hydroxide forming anion, and this anion react with BrCH2, CH2 whole 2 CH3 through the SN2 reactions. Effect of living groups, alkyl iodide greater than RBr greater than RCl, much greater than RF. Effect of solvent, you can see the normally SN2 proceed involving the reaction of anionic nucleophile with alkyl halide is suppressed in the presence of polar protic solvent such as water, since polar protic solvent will interact through hydrogen bonding. Friends, now competition between SN1 and SN2 reaction. This is very important topic for MSc students. The structure of substrate, the nature of nucleophilic reagent, polarity of the solvent, Another experimental conditions determine whether nucleophilic substitutions will take place by SN1 or SN2 mechanism. In general, primary halide undergoes substitution by SN2 mechanism and tertiary halide undergoes substitution by SN1 mechanism. Secondary halides may undergo substitution by both SN1 and SN2 mechanism. However, one mechanism may be maximized by the selection of appropriate condition, high concentration of nucleophile or presence of a strong nucleophile favors SN2, while the factor promoting the SN1 are always lower concentration of nucleophile or the absence of a strong nucleophile. Solvent of great ionizing power such as water, substrate leading to a stable carbocation, the reactions rate of both the SN1 and SN2 reactions are increased if the leaving group is a stable ion and weak base. Competition between substitution reaction and elimination reaction. This is the between elimination reaction and substitution. Beside undergoing substitution reaction, another common reactions of substrate is an elimination reaction, where the nucleophile act as the base to remove HX instead of adding to the substrate. Eliminations can therefore complete with the substitution. Many factors influence the extent of these competitions, including the nature of nucleophile, its strength, the solvent, and the substrate. The strong bulky constant base favor E2 and a strong nucleophile favor SN2 mechanical process. For instance, bulky tert-butoxide anion can abstract a proton from the periphery of the molecules but is hindered as a nucleophile. However, some anions such as thiol anion are less basic and more strongly nucleophilic. So the E2SN2 ratio increases with increased substitution by alkyl groups. Primary alkyl halides will usually undergo SN2 substitution reaction in the preference to E2 elimination reaction. As base strength increases, the rate of competitions in competitive examinations eliminations will increase, but substitution reaction complete when the base is also good nucleophile. You can see here in this how substitution or elimination occur in the same reactions. So low reactivity of vinyl and aryl halides. You can see this is the delocalizations of electron by resonance in chlorobenzenes and vinyl chlorides. High reactivity of allyl and benzyl halides. You can see allyl iodides, and you can see the orbitals of allyl form. Friends, this is the important topic SNI, substitution nucleophilic internal. It is always happen with the thionyl chloride and forming internal rearrangement. In this process, part of living group which attack the substrate detach itself from the rest of the living groups. So you can see the Dargin procedures, how thionyl group undergoing the reaction with SNI. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.